Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to start the lecture number 2 of chapter number 7, electrochemistry. And today's topic is electrolytic cell. So let's start. First of all, we will recap the lecture number 1. In lecture number 1, we have discussed about the redox reactions, that is reduction and oxidation reactions, electrodes which are anode and cathode, electrolyte which is a substance which can conduct electricity in the solution form or molten form, electrochemical cells, that is electrolytic cell and galvanic cell, and then the nature of electrochemical cells. Here we are going to discuss the first type of electrochemical cells, that is electrolytic cell. This is a cell which uses electrical energy to derive a chemical reaction. It means that in this cell electrical energy will convert into chemical energy. So the characteristics of this cell are non-spontaneous redox reactions take place in this cell. It produces chemicals from electricity and it forces electrolysis to occur. The electrode that is connected to the negative terminal of the power supply will gain electrons, and we know that gain of electron is known as reduction. So the electrode which is connected with the negative terminal of the battery that will gain electron and process of reduction will take place. Oxidation always occur at anode and reduction at cathode. So we are going to use two electrodes. One is anode at which oxidation means loss of electrons will occur, and at the other electrode that is known as cathode, reduction means gaining of electron will occur. Electrons flow through the wire and go from anode to cathode. Anions migrate to the anode and cations migrate towards the cathode, and this migration of ions will take place in the internal circuit of the electrolytic cell, where only the positive and negative ions will move towards the opposite electrodes, that is negative ions towards the anode which is positive electrode and positive ions towards the cathode which is a negative electrode. Electrolysis takes place in electrolytic cell, and we will look at the simplest type of electrolytic cell here. We will start with the two inert carbon electrodes. Inert mean which are unreactive in a single container. And then we add a direct current power supply and wires. Before the power supply is connected, the electrodes are both neutral. Using simplified symbols, we will represent a few protons by positive signs and a few electrons with a negative charge. Because they are neutral, the number of electrons is equal to the number of protons. Means in both of the carbon electrodes, electrons and protons are present in the carbon atoms, which are represented by the positive and E negative signs. When we close the switch and connect the power supply, it takes electrons from the electrode attached to the positive terminal and pumps them onto the electrode attached to the negative terminal, as you can see here in the diagram. The electrode on the left now has a deficiency of electrons because electrons moved from this electrode to the other electrode, giving it a net positive charge. When electrons leave this electrode, and the loss of electron will take place. As a result, this electrode will gain a net positive charge. And the electrode on the left now has an excess of electrons, giving it a net negative charge. In an electrolytic cell, the electrode attached to the positive terminal of the power supply is called anode. In an electrolytic cell, the electrode attached to the positive terminal of the power supply is called anode, and the electrode attached to the negative terminal of the power supply is called cathode. We will redistribute the electrons and stop showing the protons in carbon electrodes for simplicity. Add some molten zinc chloride as an electrolyte to the container. A molten salt like zinc chloride consists of ions that are in constant random motion in the electrolyte. Now we will focus on the zinc ion and two chloride ions. The positive zinc ions will be attracted to the negative cathode. Here zinc contain positive charge, so it will be attracted towards the negative electrode, that is cathode, while the negative chloride ions will attracted to the positive electrode, that is anode. Now we will concentrate on the cathode and see what happens there. The zinc ion will gain two electrons from the cathode. The zinc ions from the electrolyte, they will move towards the cathode as they are electron deficient. Positive charge show that it is electron deficient, so it is in need of electrons. So it will move towards the cathode and gain two electrons from the cathode and turn into the zinc atom. When it will gain two electrons, it will convert to a zinc atom from zinc ion. The equation for what just happened is like this. Zinc plus 2 will gain 2 electrons and convert into zinc solid. The whole equation is like this. And this gain of electron is known as reduction. So we see that reduction of zinc positive ions occurs at the cathode. Now we will have a look at the anode and see what happens. Each chloride ion will lose one electron and change into chlorine atom. Because chloride ions have excess of electrons, that's why they are represented with negative charge and they have to lose their electrons, so they will move towards the positive electrode and there they will lose their electrons. Two chlorine atoms will join to form a molecule of chlorine or chlorine gas. Actually, when these two chloride ions will lose their electrons, they will convert into chlorine atoms, and these both atoms will join together to form a chlorine molecule. And this process taking place on the anode can be summarized with an equation. Two chloride will convert into chlorine gas by losing two electrons. The process of chloride ions losing electrons is called oxidation process. And we see that oxidation of chloride ions to chlorine gas takes place at the anode. So again zinc ions are reduced at the cathode to form zinc, and chloride ions oxidize at the anode to form chlorine gas. So as this cell operates, we can visualize zinc metal growing on the surface of cathode. As zinc ions are going, again all the zinc ions are going towards the cathode, so they will lose electron, say they will gain electron and convert into the zinc metal and get deposited on that cathode. And the chloride ions, they will all move towards the anode and they will lose their electrons and convert into the chlorine gas. And bubbles of chlorine gas are shown here in this anode. So we can say that the product at the anode is chlorine gas and the product at the anode is zinc metal. So we can see here the overall reaction. First, zinc chloride ionizes into zinc ions and chloride ions. The zinc ions will move towards the cathode, that is negative electrode. Here these zinc ions will gain electrons and convert into zinc metal. And chloride ions, they are negatively charged, so they will move towards the positive electrode, that is anode, where these chloride ions will lose electrons and convert into chlorine gas. So by adding these two reactions, we will get the overall reaction in which zinc ions plus chloride ions, they will give zinc metal and chlorine gas. So by using different types of electrolytes in the electrolytic cell, we will get the products at the anode and cathode. Now some questions related to the electrolytic cell are given here. You have to write and learn the answer of these questions. Thank you. Allah Hafiz.